Alright, so today we're going to do a calculus limit. This one's pretty like a famous limit. So basically it's the limit as x approaches infinity of this, right? It's a little bit weird because you have this x as an exponent. So the first thing we do, typically with any limit, we just kind of like plug in like whatever this value is. So in this case it's infinity, so let's see if we can plug in infinity, right? So if we did that, this would be 1 plus 1 over infinity, right? Now you know that anything, like if it's 1 over infinity, it's just 0, right? So you can just, ignore that. So that's just 1 to the infinity. So what that is, that's an indeterminate form, right? So basically it doesn't, we can't use this, right? It's this doesn't give us the answer, basically. So instead we have to kind of manipulate this, just like how we manipulate other limits in calc. And so that's exactly what we have to do here. So there's actually a way to do this, but you have to use exponential and logarithms, okay? So here's how it works. So so we take this, right? So let's say it's the limit as x approaches infinity of that stuff, right? We can rewrite this, actually. So we can use e raised to the natural log of that thing, so it doesn't change the value. So we can do e raised to the natural log, ln of 1 plus 1 over x raised to the x, right? So this doesn't change it, right? It's just the same thing. Well, maybe I can change that a little bit. Okay. Well, actually, let me do this. Yeah, that's better. Okay, so basically, yeah, there you go. So natural log of all this stuff, right? So what you do is that you can take the x, that's an exponent here, and put it over here, so it's a coefficient, right? So this is the limit as x approaches infinity of e raised to the, okay, so now it's x times the ln of this 1 plus 1 over x. Okay, so all we did was just use the properties of logs and basically brought that over here. So now we have this, and it looks a little bit easier to work with. So if we were to plug in infinity here, we still have a problem, right? So let's say if we did that right now, this would be, okay, so of course x, so that would just be infinity times, okay, so if we plugged in infinity here, this would be 1 over infinity. That's also 0. And so that would just be 1 plus 0, or just 1, right? I'm sorry. So yeah, that's correct. So 1 plus 0, right, is just 1, but it's natural log of that, right? So natural log of 1 is going to be 0. So this is also an indeterminate case, so we can't use this, right? So this is not good enough. So what we have to do is we have to use L'Hopital's rule. So it only works when you have a fraction. We don't have a fraction right now, but we can change this into a fraction because we can take the x, put it in the denominator, and just make it like raised to the negative 1 power. So it'll basically be like this divided by 1 over x, right? So that way it's technically a fraction. So we'll just rewrite it in that way. So this is the limit